Hi Math 3 students, and welcome to your second 4.4 video. So go ahead and turn to page 23. We kind of left off our notes here, all right? And it says, as you may remember, improper fractions can be written in an equivalent form we call a mixed number. If the numerator is greater than the denominator, then we will divide the numerator by the denominator and write the remainder as a proper fraction. In math terms, we should say, if a is greater than b, then the fraction a over b can be written as a over b equals q plus r over b, where q represents the quotient and r represents the remainder. So that's a lot of words. Holy smokes. Basically, one way to think about this is like mixed numbers. So we kind of stopped using mixed numbers so much. Usually when you get higher up in math, you use improper fractions. But what they have here is they have improper fractions for us, and they want us to come up with the mixed number. So what they're telling us to do is you're going to go ahead and divide this. You're going to do 37 divided by 5. Okay? And when you do that, I can even do that on my calculator here. So 37 divided by 5 gives you 7.4, okay? So that means that we've got a full 7, all right? And then we have to figure out what the remainder is. So if we think about it, 5 times 7 is 35, all right? So our remainder is 2, right? To get from 35 to 37 is 2. So we're going to have 7 and 2/5, all right? So we do the division. We take our whole number, and then we have to figure out our remainder, and we put that over our number on the bottom there. All right? So let's try the same thing here. We're going to do 150 divided by 12. We get 12, and 12 times 12 is 144. We've got 6 left over, which would give us 6 twelfths, which we actually could simplify to 12 and 1/2. All right, so that's how you go from a improper fraction to a mixed number. All right, so now we're going to try that for polynomials, or these rational expressions. So if you look at if you look here, they want us to identify if it is proper or improper, and if it is improper, we have to write it in this form, which means we have to divide it and find the remainder. So let's go ahead and give this a shot. So number 13 is going to be improper. All right. So since it's improper, we're going to go ahead and divide. So we'll do x plus 2 divided by x squared plus 5x plus 7. So we'll go ahead, we'll say x squared divided by x is going to give us an x up top. Then we're going to go ahead and multiply. We get x squared plus 2x, and then we got to change the sign. So we'll do a minus, and this will change to a minus. So then we've got 0 and 3x. All right. Then we're going to go ahead and bring down our 7, and we're going to do 3x divided by x gives us a 3. We'll multiply. We get 3x and 6. We'll change our signs. Minus, minus, which gives us a 1 as our remainder. So our answer here is going to be what's on top, plus our remainder over our bottom. All right. So let's take a look at, I guess I didn't talk about why this was improper. Sorry, guys. The reason this is improper, we talked about this yesterday. The degree on the top is 2, and the degree on the bottom is 1. Since the top is bigger than the bottom, it's improper. All right, let's check out 14. Is it proper or improper? So the degree on the top is 1. The degree on the bottom is 3. So this one is actually proper. So when it is proper, you do not divide. All right. You might be able to simplify at times. So like think about if you think about 6 twelfths, this is proper, but you could simplify it. But you really can't divide. All right. Okay, let's go ahead and try 15. So our degree on the top is 2. Our degree on the bottom is 1. Now, how am I finding out the degrees? You have to figure out the highest power on an x value. All right. This one is improper. So we're going to go ahead and divide. So we're going to say x plus 3 divided by x squared plus 2x plus 5. We'll do x squared divided by x gives us an x. Multiply x squared plus 3x. Change our signs. It's going to give us negative x. Bring down our 5. Negative x divided by x gives us a minus 1. We multiply, we get negative x minus 3. Change our signs. Those cancel. And we get 8 as our remainder. So our final answer here is going to be x minus 1, which I got from up here, plus our remainder over x plus 3. All right. So now let's go ahead, we'll skip 16, and we will try, excuse me, sorry guys. We will go ahead to the next page here. So it says, in 4.3 rational thinking, when we looked at the graphs of rational functions, we did not consider the case where the numerator of the fraction is greater than the denominator. So let's take a closer look at the rational function from number 13. So that was that first one we did here, all right? Let f of x equal this function. Where do you expect the vertical asymptote and the intercepts to be? All right, so we can go ahead and give that a shot here. We could say our vertical asymptotes, right, we're going to get from setting the bottom equal to 0. Right, and we've got x equals negative 2. And then we can see, when we set this top equal to 0, it's actually kind of ugly, I'm going to be honest. Vertical asymptote and intercepts. Okay, so let's see. So we can get our y-intercept from plugging in 0, right? So we could do 0 squared plus 5 times 0 plus 7 all over 0 plus 2. This is how we get our y-intercept. And you end up with 7 over 2. So you could have 0 comma 7 over 2 for your y-intercept. And then your x-intercept, we have to set the top equal to 0, which actually ends up being quite ugly. You can't factor it. You can't factor x squared plus 5x plus 7. So when you can't factor, or honestly, if it's too hard to factor, let's say you're looking at something like, I don't know how to factor that, you have to use quadratic formula. All right. And spoiler alert, I'm just going to tell you, when you use quadratic formula, you end up with this, which gives you this. Okay, so it doesn't have any x-intercepts. This is imaginary, right? It's got an I value, so you would say no x-intercepts. All right. Right. So that's where we got from that. So then and then we know for the horizontal intercept, we have to look at the two cases, right? We said, okay, well, when the powers are the same, you look at the coefficients. When the bottom is bigger, it goes to 0. But we don't know what to do for the horizontal intercepts. That wasn't on that chart that we dealt with. So for number 17, it says, use technology to graph the function. Relate the graph of the function to the equivalent expression you wrote. What do you notice? Okay. All right. So let's go ahead. Let's graph this. So I did graph this on Desmos, and you can see this is our original function, all right? And they said they want you to graph it with the original expression here. So what I did is, remember when we divided, our answer was x plus 3. All right, we did have a remainder, but our main answer there was x plus 3. Watch what happens when I graph x plus 3. Do you see how it kind of follows that x plus 3 thing going on there? So that is actually what we call a slant asymptote. All right. So there appears there. Oh my God, why are you not writing, pen? That's not good. Sorry, guys. Hold on. It's just like class. There is a slant asymptote. All right. So then it says, let's try the same thing with number 15 and relate that to the equivalent expression. So let's go ahead. I will do the same thing and graph it. So we've got x squared plus 2x plus 5 divided by x plus 3. All right. And then we'll go ahead and we're going to graph. If we look, we got x minus 1 is our answer. So let's see what happens when I graph x minus 1. You can see again that that is, in fact, a slant asymptote. So we could just say we have a slant asymptote at y equals x minus 1. It's just a line, right? So basically the last question asks us, how do you find these slant asymptotes? You have to divide. So you use division to find slant asymptotes. All right.